Hi everyone. What we are looking at today is not really new content. There's nothing here that you don't already know how to do, but it's a specific type of free response question that comes up on just about every version of the AP exam. Okay, and it's referred to as the rate in, rate out problem. Okay, and so what this question has to do with is exploring that relationship between rates and like accumulation. Okay, so I'm just going to, before we start with the specific example, I just want to remind you that in calculus we're typically looking at two different things. We're looking at equations that tell us the amount of something, or we're looking at equations that give us a rate of some kind. Okay, so if I'm looking at people entering a store, okay, I can talk about the number of people who have walked through the doors, or I can talk about how fast they're entering. Okay, if I'm talking about position, I can talk about distance, which is miles or feet or whatever, or I can talk about how fast you're moving, like a rate of change, a velocity of some kind. And we're going to be moving back and forth between these two things. So remember that the way we get to a rate from an amount is by taking a derivative. Okay. And the way we get from a rate back to an amount is with an integral or an antiderivative. Okay, we also usually need an initial condition here, but this is what we're going to want to keep in mind, because what these problems tend to do, not always, but they tend to start you with equations for rates and then ask you questions about the amounts of things, and that's always going to take some integration. Okay, so I'll show you kind of the key pieces of this problem here. We're going to assume that this is a calculator active question. I made up these functions, and I certainly did not make them ones that you could do by hand. So just reading through here, a tank at an aquarium is being filled with a hose. Water is filling the tank at a rate, all right, this is important, of this function, okay? And so this is your in function. This is the water going into the tank. At the same time, water is leaving the tank. Water is being pulled into a filtration reservoir. So this right here, and again, this is a rate function, but this is your out function, okay? And then a lot of the times there will also be an initial value, okay? So when this process begins, there were already 15 gallons of water in the tank. So this is our initial amount. And it is an amount, not a rate, okay? So the first question here is, how much water has been pulled into the reservoir after 3 hours? And actually, you know what, before I start that one, I'm going to do something that's going to make our calculator life a little easier here. You might want to follow along with me, and I can go over this in class with you too, but we're going to be using these functions a lot, and I don't want to have to keep retyping these functions in every time, okay? Every time I take a new integral or every time I want to evaluate a derivative. So this is a trick that we have not used before, but it can really be a time saver for you. I'm going to type the first equation here into y1. I don't really care about actually graphing it, but I'm going to show you what this will do for me. This is going to be tricky to get typed in, so I want x minus 4 squared and then divided by 5. And then close my parentheses from the sine function. And that should be the first one. That's my in function. So I'm going to make a note here that this is y1. And then in y2, I'm going to do the out function. So that's 3x minus e to the power of x over 2. Okay? And that's my out function. Now, we could take a look at the graphs of these. I don't know that this is going to be like super helpful to see the picture, but there is something we can do here in a minute that's going to make it so we don't have to retype this every time. Okay, let's go back to what we were talking about though. How much water, so before I go any further, how much is asking me for an amount? It's asking me for a quantity. So right away my brain is going into integration mode, okay? And it says how much water has been pulled into the reservoir, so that's this water, right? That's how much water has been pulled out after 3 hours, okay? So if I'm trying to get an amount from a rate, what I really want to do is an integral for 3 hours, so from 0 to 3 of the r of t function. And I am allowed to just write it this way because it's already been named as r of t up above. So this is the integral that I'm going to evaluate here. And here's where the calculator magic comes in. I want to do an integral, so math and number 9. Excuse me, sorry guys. I want to go from 0 to 3. And now, instead of retyping my function, I can tell my calculator, hey, my function is listed under y2 in my y equals. And the way I do that is I go to this button that says vars, V-A-R-S, that's variables. And I'm going to go over to where it says y variables. I'm going to choose function. Sorry, I forgot about that screen. And then here I can choose which one of my y equations I want to use. So I'm going to say this is y2 that I'm talking about. And your calculator will automatically go grab it from where you have it in y equals. And that's a really useful thing if you are going to be retyping these equations over and over again. Okay? I'm still integrating in terms of x, and then I'm going to hit enter, and it looks like 6.537 gallons. That's how much has been pulled in, and again, that's an amount, so that's why I'm labeling it gallons, have been pulled into that filtration system. Okay, next one. This is probably the bigger deal. In fact, I'm going to get a different color for this. Oh, no, just kidding. Yeah, write a function to represent the total amount. That's what I thought it was. Okay, the total amount of water in the tank. So this is taking into consideration the ins and the outs and the everything. But it is an amount question, right? So I'm going to write a new function, and I can do this on the AP test too. I can decide I'm going to name this W of t, which is the total amount of water after however many hours. Okay. This question is specifically for after 8 hours, but I kind of wish,